Hello 108 students, Mr. McHugh here with you. Welcome back to section 8.1, page 2, 8.1 radicals. I'm going to finish up example 2 here, taking more square roots and cube roots and fourth roots. And basically, just remember that if you see a radical sign without an index number, there's assumed 2 there. We hardly ever write it, like I said. So what times what equals 100? The answer 10. If they put the negative, bring that down on the outside, so square root of 100 is 10. Bring down the negative and you're okay. Here's an interesting idea. What's the fourth root of 81? These are all perfect square roots, cube roots, and fourth roots here. We've got our calculators. You could punch us in your scientific calculator now, but these ones are fairly easy. Just ask yourself what times itself 4 times equals 81. So that's how I go these. What times itself 4 times equals 81? The answer is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3, 81. They put the negative sign, you put it on the outside, and you're on your way. Now here's something interesting. Can you take the fourth root of a negative number inside? And the answer is if it's an even root, the answer is no. If it was an odd, remember how we had the cube root of 8 from the previous example, and that answer was -2, because -2 times itself 3 times does equal -8. Okay, so there you go. Now the big thing we want to cover here on this page 2 of our class notes is graphing. Okay, we want to get this correlation of taking square roots and cube roots, and what would the graphs look like. Okay, and so this is kind of exploring, trying to understand some concepts, the functions of input. Take the square root or cube root, that's the process. The output will be y. Okay, so these are called parent graphs. Again, this is the simplest one you can have. Y is your output, x is your input, the process is the square root. So give yourself some values. So I just started off with 0, and square root of 0 is 0, so you start off at the origin. Okay, square root of 1 is 1. You can kind of see these. Square root of 4 is 2. Square root of 9 is 3, and the graph goes like this, and it keeps going on and on forever. So it's a function, and you're on your way. Notice we did not put the square root of -4 because it doesn't exist, so that's why the graph stops there. Okay, cube root functions, same idea. Again, the expanded xy tables. Now you can start with a -8, because can you take the cube root of -8? And the answer is the result is -2. So plot these ordered pairs. 8, -2. I find these patterns very interesting. These graphs. Cube root of -1 is -1, so you're at -1, -1. Cube root of 0 is 0. Cube root of a +1 is a 1, and finally the cube root of 8 is 2. And you kind of get a propeller graph going here. Okay, and so these are the parent graphs. So we're going to do some homework problems on the next page here to help you with what you'll see, but study these. Make sure you feel comfortable with them. Okay, Mr. McHugh here. This was a fairly quick page 2, so good job on that one, and I will see you for page 3, and like I mentioned, we'll do some more graphing, and we'll wrap up section 8.1. Okay, take care. Bye.